Hey guys, today we're going to talk about aluminum TIG welding using alternating current. And we'll start by talking about some of the properties of aluminum that can make it a little difficult when you're first starting out. And then we'll do a good project for you, which is a surfacing plate to get a lot of experience welding aluminum, dabbing, and to kind of build up your rhythm going through this project. And, there's a few things about aluminum that can make it seem difficult, such as the oxide layer, which we need to remove first before we weld aluminum. The high rate of thermal conductivity, meaning that the heat moves quickly through the material, which is very different from some of the other materials that we've been welding so far. It has a low melting point, and it has a melting point of about 1200 degrees. Compared to other materials, that's pretty low. That, coupled with that high thermal conductivity, creates kind of a weird thing with the heat moving quickly through the material, but once you get to that low melting point, can make it easy to melt through the material very quickly. So we'll talk a little bit more about that as we get into the procedure here. And then we also have high rates of distortion, which can give us difficulty in fabrication. Higher rates of distortion than we would see with carbon steel or other materials like that. So that's what we'll be talking about today, and we'll get a little bit more into it now. All right, so the project that we're going to do to get started is this surfacing plate. And like I said before, this will give us a lot of experience welding aluminum, just putting beads on the surface. And we're actually going to create a new surface. So we're going to slightly overlap each bead and create a whole new surface here. And we can do this on both sides of the plate. And by the time we get through both sides of this plate, we can even do multiple surfaces on each side, make a brick of aluminum. And by the time we get done with this, our speed and our efficiency and our quality will be a lot better than when we started out. And this is what I did when I first started welding aluminum, and it really built my speed and my ability to move the filler through my filler rod hand. And just overall, I got a lot of arc time on this one piece of material, and it improved my skill pretty quickly. So that's what we're going to do today. So the first thing that we need to do is properly prep the material. So aluminum is a very reactive material, so it's going to be very susceptible to contamination just on the surface of the material, or if our shielding gas isn't efficient enough. So we need to do a good job of cleaning the material and making sure our shielding gas is efficient. So for this, today I'm going to be using a gas lens setup with a size 8 ceramic cup. And, this depends on what size material, how much amperage you're using, all that kind of stuff. But for this particular project, that's what I'm going to be using. So we can get a good size piece of aluminum, either 1/8 inch or higher. We want a little thicker aluminum if we can find it, because we're going to be putting a lot of heat into this material, and we're going to need to manage that heat effectively. So the thicker the aluminum, the better, without getting too ridiculously thick. So either an 1/8 inch piece on up to, this is like 3/16 or 1/4 inch. This is also good. This is a great piece of aluminum for this project as well, but it'll take more heat. Okay, so the first thing that we need to do is we need to clean this oxide layer. And as I said before, the oxide layer builds up over time. When this aluminum is produced, immediately when it is subjected to the atmospheric air, it starts to build up this oxide layer. The oxide layer has a higher melting point than the base material. So The oxide layer it has a melting point about 3,600 degrees, where the base material of the aluminum actually melts at 1,200 degrees. So if we just try to weld it without breaking up that oxide layer first, that top layer will not melt, and it'll just start to kind of move around on the surface because that bottom layer, the base material, is starting to melt underneath. And then you'll also see it'll start to kind of contaminate that weld pool as it starts to break up. So we need to clean that up first with using a wire brush. And the thing that's important about this is that we just lightly, use a nice even pressure on the material as we go back and forth, not to press too hard because that can embed the oxide layer into the surface of that soft aluminum material. And so then we also want to only use one direction. Don't change directions because that can also embed it in there. And just a nice even pressure. So I'll show you how we do that now. So I'm just going to pick one direction. We can see the difference between the areas that we've brushed and the one that still has the oxide layer intact. Okay, so now these areas are ready for welding, and we need to keep this in mind that on different types of projects, or maybe a T-joint or a lap joint or something like that, we need to clean any areas where we're going to be welding. So if we're doing a T-joint, we would need to clean the area in the middle as well as the bottom of the piece that would connect there for our T-joint, okay? Otherwise, we're going to have difficulties welding it. All right, so that's as far as cleaning up the oxide layer, that's what we'd want to do. And then also, because it's very prone to contamination, we would also want to clean the surface with a cleaner like isopropyl alcohol or acetone to remove any contaminants. And typically what we do in industry is we clean the material first with either alcohol or acetone, and then we brush our areas that we're going to be doing welding, and then we clean it again with those solvents to be able to remove any excess oxide or further contamination that was still left there. And that's going to give us our best case scenario in terms of cleanliness and weld quality and appearance. Okay, there is going to be some oxide layer that's left over in there, but the DCEP side gives us some cleaning action from that AC welding circuit, and the DCEP side will give us some cleaning action which will break that up further, and that's that sort of hazy line that you see on the outside of your aluminum welds is the cleaning action that I'm talking about. Okay, so that's how we'll prep the material first, and then we're going to start to put these beads on, these surfacing beads onto our plate. And the thing that I wanted to point out is that you notice from mine, I have this very distinct border all the way around. We want to make sure that we aren't going all the way and breaking that edge on the border, because that low melting point, if we break the edge of the plate, it's going to melt away that edge. And there's nothing really wrong with that, but if you want to be left with a nice piece that you can kind of keep, and something that is appearance-wise is nice, you don't want a bunch of edges blown out on your plate. So keep a border all the way around that. Okay, so we're going to pick one direction. If we have a piece that's like this, most likely where we want to start is going this direction, because that will give our overall amount of welding time, amount of arc time it will shorten that up, which means that we'll get less heat input with each weld, which will help you to control your heat input a little bit with this project. You're going to see that over time, you're going to need to give it time to cool down. You might get about 3 welds in before you need to let it sit and cool down. You can use a heat sink, a larger piece of aluminum to pull some of the heat out of it, or put it in front of a fan, or even quench it. Just make sure that the water is nice and clean so you don't contaminate the material. Okay, so I'm going to finish brushing this side, and then we'll go ahead and we'll put our first bead down. All right, so we're going to put our first bead down on this plate, but the thing that I wanted to talk about first is just what I see with a lot of new welders when they're first starting out on aluminum. Keep in mind, we have high thermal conductivity, so especially when we're on a cold piece of plate like this, where haven't put any welds down, we don't have any heat in that plate yet. So it's going to take a moment for us to get that weld pool started. So we need to wait for that weld pool to start to get a nice hot weld pool before we start adding our filler metal. So, if you don't wait for that and you go to put this filler metal in, it's just going to ball up on the surface, and then that AC circuit that's going back and forth is actually going to kind of, a lot of times it just will suck some of that filler metal that's loose on the surface against your tungsten, and it'll just kind of blow up and you won't really know what's going on. So make sure that you see the weld pool. It should look like a little mirror or like mercury forming on the surface. And that's how you know that you've got, a nice hot weld pool. So wait for that to start first, then add your filler metal to that. And then once you have the piece saturated with heat, then it's a low melting point. So it's 1200 degrees, and it's going to come a lot quicker, and you'll be able to pick up where you left off a lot faster. So just know that going into it, that it may take a longer period of time for you to see that weld pool than it did with, say, carbon steel or stainless steel. Okay, so let's go ahead and get started. All right, so we have our first pass on, our first bead, right? And now we're going to start overlapping the beads. So we're going to put our second bead right next to it, but we want it to overlap by maybe 1/16 of an inch or something like that to actually surface the plate. So we don't want any space in between. So we're going to put the next bead right next to it and overlap that toe. And we're being careful not to go all the way to the edge, all the way around. Now, the other thing that's very, very important with aluminum welding, and we see this a lot in aluminum welding, is to reduce the crater. So we don't want there to be a crater at the end of our weld. That's the hottest portion of our weld. We're going to get a lot of shrinkage, especially in aluminum, because we have that high thermal change in size from heat, which causes that higher rate of distortion that we're talking about. So we have to add a little bit more filler metal at the very end of our bead. And then I also, if we're using a pedal, I like to back off of that amperage very slowly and even move my tungsten around just slightly to agitate that weld pool a little bit to reduce the amount of cratering. The problem with the crater is that that's where cracks will propagate in our aluminum welds, especially if the amount of filler is very thin there. So make sure that you're filling your craters and that you're developing that good habit right now, because the habits that you develop now, especially when you're first starting out on something like this, where you're doing a lot of repetition, you want to develop those good habits so that you have that muscle memory of filling your craters. Okay? Also, watch your tungsten. as you dip into the weld pool, the hot aluminum is going to expand in size. So when you dip into the weld pool, that weld pool is going to come up. And if you're too close with the tungsten, it'll actually hit your tungsten. And that's very common when you first start welding aluminum as well. So if it comes up and it hits your tungsten and contaminates it, just stop and go clean up your tungsten, because as soon as you start to see that shape change on your tungsten and it gets real contaminated, you're not going to be able to control your arc very well. And so you might as well just stop and go clean up your tungsten, okay? All right, so those are the two things to watch. So now we're going to start to surface this. And like I said before, especially, I've got a fairly fast travel speed. So I can get away with maybe 3 or 4 beads in a row, maybe a little bit more than that. But you're probably only going to be able to do maybe 2 or 3 at a time, then let your plate cool down a little bit, or maybe switch between a few different plates so that you can manage your heat effectively. And then also we're going to get high rates of distortion. So if we did all of our beads on one side all the way across, we're going to end up with a potato chip. Okay, so as you're putting beads down, flip it over, do the other side, make sure you brush it first, and play with that heat input control to manage that distortion so that you'll end up with a somewhat flat plate when you're done. It's not going to be completely flat, but you don't want to end up with a taco or a potato chip, okay? All right, so let's go ahead and put in some additional beads. All right, so we got about 4 or 5 passes on this plate. We're going to let it cool down and flip it over and start on the other side to manage that heat, okay? In the meantime, I wanted to talk about advancing our filler metal through our hand. And this is really going to develop that, because you're going to be dipping real quick, and you're also going to be going through a lot of filler metal, because each time that you dip, especially with 3/32 like this, you're going to really want to push a little extra into the weld pool so that it doesn't flatten out that bead too much, okay? So each time that I'm dipping, as I dip, I'm also pushing in a little bit, and that's with these front 2 fingers. So I'm pushing that in as I'm dipping in with my hand movement. And then the other thing is, once we start running out of rod, then we need to advance more through our fingers. And that's a combination of these 2 front fingers and my thumb. So I'm actually using my thumb to push it in, okay, to push that through. So we can also just practice this movement, just using an extra piece of filler metal when you're sitting on the couch or you're scrolling Instagram or something. Hold a piece in between your fingers and get used to getting a piece through quickly, because that'll help you while you're under the hood. If you get stopped up and you don't know what to do, you're having trouble getting enough through, back way off that pedal, not so, that the arc extinguishes, but back almost all the way up so that you just have a very small arc, and then get more in your fingers and then continue to dip. And you can do that several times throughout the weld until you feel more comfortable, okay? So that's advancing filler rod through your fingers. All right, and so you'll just continue on both sides, overlapping those beads, giving it some time to cool off when that bead gets out of control. If you start to see it get real wide and spread out and you just cannot control it no matter what you do with that, with the pedal, then it's time to just let it sit for a while. Another thing is, I started out at 140 amps for my very first bead, but then I'm turning it down 5 amps at a time The lowest that I go is probably 125 or 120. And then, you know, when it just gets to the point where at 120, it's really, really hot and really the weld pool is really, really fluid immediately, then I'm just gonna stop. You just gotta let it cool down. Okay, you can quench these, but you're adding a lot of hydrogen to your material, and if you don't let it sit and you don't let it completely dry out, then you're going to get contamination. Moisture is not aluminum's friend, and it's very, very you know, porous. So in the welding process, you're better off not quenching. You know, at the end, if you just want to cool it off quickly, then you can quench it. But if you're still going to be doing some welding on it, you don't want to add that moisture to the material. Okay, so keep on it, you know, just keep working on it, but always with welding, slow is fast. Don't be in a hurry, you know, let it cool down in between, and you'll have a lot better luck, okay? So there you go. We've surfaced both sides of this plate, all the way on both sides, overlapping each bead by about 1/16 of an inch or to 1/8 of an inch, something like that. And if we surface both sides, then we can even switch directions and put a new layer on both sides, and just keep doing that, managing the heat. And over time, you'll get a thicker piece that will be able to take more and more heat. And you know, you get a few layers of beads on this plate, that's quite a bit of arc time. And you know, you'll get to the point where you can almost do it with your eyes closed. At that point, you have so much muscle memory built up. So again, this is just a great project that you can start with when you're getting used to dabbing aluminum, to really build up that arc time with minimum use of material. I used a combination of 3/32 and 1/8. Honestly, the 1/8 though, by the end, it handles the heat so much better, and I actually prefer the look of the beads with the 1/8 inch filler rod versus the 3/32. So if I were to start over again, I'd use 1/8 inch from the start. Okay, so that's the aluminum surfacing plate, and again, a great project to get started with. So hopefully you found this useful to you. If you have, make sure you like this video, subscribe, and tune into the channel for some more helpful videos. All right, we'll catch you on the next one.